I will run make deploy local to deploy VMware Secrets Manager locally. This action will install VSecm Safe, VSecm Sentinel, and Spire. Next, let's talk about cluster SPIFFE IDs and their role in assigning identities to our workloads, including our core components, such as VSecm Safe and VSecm Sentinel. As always, if you find value in what you learned today, please give us a star on GitHub at github.com/VMwareTanzu/Secrets Manager. Your support helps others discover this incredible technology. Back on track. A cluster SPIFFE ID is a Kubernetes custom resource that identifies workloads in the cluster that Spire knows about and can dispatch SVIDs to. To remind you again, SVIDs are X509 digital certificates that Spire distributes to workloads for them to identify themselves. They can be used for secure MTLS connection between workloads. When I run kubectl get cluster SPIFFE ID, I'll get a listing that contains VSecm Safe and VSecm Sentinel. This shows that Spire knows Safe and Sentinel and can dispatch identities to them. Let's describe the cluster SPIFFE ID of VSecm Safe. This is the SPIFFE ID that VSecm Safe will receive, and a SPIFFE ID is a string that uniquely identifies a workload. It is a part of SVID. When SVID is an X509 digital certificate, the SPIFFE ID is in the SAN, subject alternate name, of the SVID with which the workload is assigned. This CID also defines some workload attestation preconditions for Spire to assign the SVID to the workload. This way, you can prevent other workloads in the cluster from impersonating VSecm components, providing fine-grained security. Also, we see that we have one pod selected, which means Spire can dispatch identities to one pod, which is VSecm Safe. Let's do the same for VSecm Sentinel. kubectl describe cluster SPIFFE ID, VSecm Sentinel, and we get this output. Again, we get one pod selected. Now let's check the pods in our Spire system namespace. Kubectl get PO, Spire system, and we have Spire server and Spire agent healthy and ready to serve. For the record, this restart you see in the Spire server or Spire agent is normal. The server and agent can restart several times during bootstrap, but they'll eventually reconcile into a stable state. Similarly, when we run kubectl get PO VSecm system, we'll see that VSecm Safe and Sentinel are healthy and ready to create and dispatch secrets. You can also check the logs of VSecm Safe by using kubectl logs, pod name, -n VSecm system. VSecm logs can be helpful when things don't work as expected. We successfully built and deployed our system locally by running make build local followed by make deploy local. Now, let's test our system and ensure it's in good shape by executing make test local. This will run a series of tests to ensure that VMware Secrets Manager is working as expected. If these tests fail, there might be a problem with your setup. Now, I want to run the same tests, but while running them, I'll also tail VSecm Safe's logs to show you what's happening on VSecm Safe, which is our secret store. At the bottom terminal, I'll tail VSecm Safe's logs with this command, and at the top terminal, I'll run make test local again. So let's do it. And yes, all tests passed. And everything is indeed awesome. Next up, we'll dive deeper into VSecm configuration. And until then, keep your secrets secret.